Welcome back to the Optimization Method course and Happy New Year to us all. May everything become better this year. So today I'm going to talk about n-person game theory, and this is different with the previous weeks where we only talk about two-person games. So let's start. So this condition is common because in many competitive situations we have more than two competitors. And then let's say we have n players and the big N is the set of all players. So we have player 1, 2, up to player n with the small n. An n-person game is specified by the game's characteristic function. So this is the first concept that we need to learn, that is called characteristic function. So it says that for each subset S of n, the characteristic function v of a game gives the amount Vs. So Vs is the amount that the members of S can be sure of receiving if they act together and form a coalition. So S is a subset of these players. So if one or more players act together, form a coalition S, then they will be sure to receive the amount of Vs. And then we will define Vs for each subset S of n. So we list all the subsets for the set n, and then we define the amount that the coalition S will receive if they act together. So that is called the characteristic function of this game. So in other words, we may determine Vs by calculating the amount that the members of S can get without any help from players who are not in the coalition S. There is a property that the characteristic function must satisfy. It is called the super additivity property. This property says that, let's say we have two players, A and B. If A acts alone, he or she receives VA. If B acts alone, he or she receives VB. Now, if they form a union or a coalition, then the value that they receive after they form the coalition must be greater than or at least equal to the sum of the values they receive when they act alone. So it is impossible to say that after they form the coalition, the value that they receive is less than the sum of what they receive if they act alone, right? So that is called the super additivity property. So if you think about it, let's say A does a business by himself or herself, and he or she receives a certain kind of profit. And then B also does his or her own business and has his or her own profit. If they act together, this property says that the total profit must be at least the same if you take the sum of A's business alone plus B's business alone. It cannot be less than that, okay? Now let's see an example. In this example, it says that Joe Willie has invented a new drug. However, he cannot manufacture the drug. He just has kind of like the recipe of the drug. So he can sell the drug's formula to company 2 or company 3. The lucky company will split a $1 million profit with Joe Willie. And from the side of the company does not have the formula. So it can manufacture the drug, but it does not have the formula. From the Joe Willie side, he has the formula, but does not have the ability to manufacture the drug. So the question is, find the characteristic function for this game. So here we have three players. Joe Willie, company 2, and company 3. Remember, for the characteristic function, we need to find a value that each subset of the players may receive in this game. So we need to define the subsets first, and then we see how much value that subset of coalition receives. So we have three players. The subsets that we have are empty set. Remember the set theory, empty set is also a subset of a bigger set. We have the set of 1, player 1 by himself, set of 2 only, the set of 3 only, and then we have the set of 1 and 2, 1 and 3, 2 and 3, and the set of 1, 2, 3. So those are all the subsets that we have for this example, right? Okay, now let's find out what is the value that each subset will receive in this game. So if it is an empty set, the convention is that the value is 0. So empty set is 0. If the set contains only Joe Willie, player 1, then the value that Joe will receive is also 0, right? Because Joe has only the formula, but he cannot manufacture the drug. So there is no profit because he only has the formula, but he cannot manufacture the drug. Similarly, if the set or the coalition contains only company 2 or company 3, then the value that company 2 receives is 0. Also, company 3 will receive 0 if company 3 acts by itself, because it may manufacture the drug, but it does not have the formula. Also, if the companies form a coalition, company 2 and 3, the value that they will receive is 0 because they have the ability to manufacture the drug, but they do not have the formula. Okay, so that's why all the subsets in this row, the characteristic function value equals 0. Now, if 1 and 2 forms a coalition, so Joe Willie and company 2, or 1 and 3, Joe Willie and company 3, then this coalition will receive $1,000 of profit because Joe Willie has the recipe and the company, either company 2 or company 3, has the ability to manufacture the drug. Similarly, if all players in this game form a coalition, 1, 2, 3, then the profit that they receive in total equals $1,100 because Joe has the recipe, and then both company 2 and company 3 have the ability to manufacture the drug. Okay, so this is the characteristic function for this game. So this coalition of all players in the game is called the grand coalition. And then for the empty set, we call it empty coalition. And by convention, the value for empty coalition equals 0. Now here's the next example. It's called the garbage game. So each of 4 property owners has 1 bag of garbage and must dump it on somebody's property. So not on his own property, but somebody else's property. If B bags of garbage are dumped on the coalition of property owners, then that coalition receives a reward of minus B. So if you receive 1 bag of garbage, you or your coalition, then your reward is minus 1. If you or your coalition receives, let's say 2 bags of garbage, then your reward becomes minus 2. Okay, find the characteristic function for this game. Okay, same as before, we need to define all subsets of this game. We have 4 players, so the grand coalition is the coalition of all the 4 players. And then for the other subsets, we can say that based on the members in that subset, we can define V for the subset S if the number of members in S is less than 4. Okay, and then for the empty set, it is not mentioned here, but the empty coalition, by convention, the reward is 0. Okay, so let's see the reward that each coalition receives. If it is a grand coalition, then everybody in this player is in the same coalition, so the reward they receive is -4, because you have 4 bags of garbage, but then everybody in the game is in the same coalition, so then you cannot throw away the garbage anywhere, so your rewards becomes -4, right? You have 4 bags of garbage, you cannot throw it anywhere, and everybody is in the same coalition, so the reward is -4. You or your coalition receives 4 bags of garbage. Now, it's quite different if the subset does not contain all members in the coalition. Let's say this coalition S contains 3 players. So something like this. 3 property owners are the yellow coalition, and then just 1 property owner becomes the dark blue coalition. So in this case, the yellow property owners will throw their garbage to the blue property, and then the blue property throw the garbage to the yellow coalition. As the result, the yellow coalition, which contains 3 players, will receive the reward of minus, and then inside the brackets 4 minus 3, because there are 3 members in the yellow coalition. So the reward for this coalition is -1, right? You can see here in the illustration, this yellow coalition receives 1 bag of garbage. On the other hand, the coalition of the blue property owner, just by itself, it will receive minus of 4 minus 1, so that is 3, and then so it will receive the reward of -3. Okay, because it receives 3 bags of garbage from the yellow coalition. Let's say another example, if the blue coalition consists of 2 property owners, and then the yellow coalition also has 2 property owners. Then we can say that the V for the blue coalition is -2, because it receives 2 bags of garbage from the yellow, and then the V for the yellow property owners coalition is also -2. Here's another example that is called the land development game. It says here that player 1 owns a piece of land and the value of the land is $10,000. Player 2 is a subdivider who can develop the land and increase its worth up to $20,000. Player 3 is also a subdivider who can develop the land and increase the worth of the land up to $30,000. There are no other prospective buyers of the land. Find the characteristic function for this game. We have 3 players again, and then the subsets are empty set, and then player 1 only, player 2 only, player 3 only. 1 and 2 forms a coalition, 1 and 3 forms a coalition, 2 and 3 forms a coalition, and the grand coalition of everybody. Okay, so if 1 acts only by him or herself, then the value that this person receives is $10,000, so only the land. But if we only have the subdividers acting alone, then the value that subdivider 2, subdivider 3 receives by themselves equals 0 because they do not have any land. Okay. If 1 and 2 forms a coalition, the value they receive is $20,000. If 1 and 3, the value is higher, become $30,000 because 3 can increase the land's worth up to $30,000. If only the subdividers form a coalition, they receive nothing because there's no land again. And then for the grand coalition, the reward they receive is $30,000 because there's a land and then there is player 3 who may increase the value of the land up to 30,000. So that's the characteristic function for this game. Now we have defined the characteristic function of a game in which we say that this is the amount that this subset or coalition will receive. Now let's talk about the actual solution. There are many solution concepts for an n-person game. Solution concept here means the reward that each player actually receives. We may represent the solution concept as a reward vector x. So x1 is the amount that player 1 receives, x2 is the amount of player 2 receives, and so on up to xn. Okay. Now the reward vector must be rational. It means that it must satisfy the group rationality and also individual rationality. For the group rationality, it means that the sum of this reward for all players must equal to the characteristic function of the grand coalition. Okay, so the characteristic function of the grand coalition means that if everybody in this game form the coalition, they act together, everybody, then that amount is the reward that you may give to the players, such that the sum of the rewards that all players receive must equal to the amount that the grand coalition may achieve, right? If it is if the sum of these rewards is greater than the characteristic function of the grand coalition, then it's weird, right? Like everybody already acts together and get VN. Now you say that you can give more money to the players. Like where does the money, additional money comes from? So it does not make sense if the total of money or reward that you give to the player exceeds the characteristic function of the grand coalition, right? Because grand coalition means that everybody in the game has already acted together, put all their efforts, and that's the amount that they can get in total. Similarly, if the sum of the reward for all players less than Vn, it's also weird because this game, if everybody acts together, can result in the reward of this much. But then the amount of reward that you give to the players, the total is less than that. So where does the money go, right? So both way, it does not make sense. It must be that the total sum of the reward for all players equals to the characteristic function of the grand coalition. Otherwise, it's just something irrational happens, right? And then individual rationality means that the reward that is given to player I must at least equal to or more than the characteristic function for Vi. This is the case because if you give the reward to player I and it is less than what he or she can get by acting for himself or herself, then surely that person does not want to accept this solution concept. This solution concept, right? Let's say if I act by myself doing a business, I will get the profit of 100. But then this solution concept says that I will only get 50. Then I will not accept this solution, or this solution cannot happen, right? Because um, in the worst case I act by myself, I will receive 100. So there's no way that there's a solution concept saying that I can only receive less than 100. Okay, so these are the two rationalities that a reward vector must satisfy. And then if a reward vector satisfies both group rationality and individual rationality, it is called an imputation. So for the land development game, we are going to look at these four reward vectors and see which one is an imputation and which one is not. So this is the characteristic function for the game. And then here are the two rationalities that a reward vector must satisfy to be called an imputation. For the first reward vector, it is an imputation because for each player, we are looking at individual first. For player 1, the reward is greater than or equal to V1. For player 2, the reward $10,000 is also greater than V2. For player 3, the reward is also greater than V3. So individual rationalities for all players are satisfied. And then the sum of these three also equals the characteristic function of the grand coalition. So again, it satisfies the group rationality. So this is an imputation. For the second vector, however, for example, we examine this reward 5,000 for player 1. It is less than V1. So it does not satisfy the individual rationality for player 1. Once any of the rationalities is not satisfied, we can say it is not an imputation. For the third reward vector, again, we see, for example, for player 3, the reward here is minus 1,000. It is not rational from this viewpoint of this individual. Because if player 3 acts by himself, he or she receives 0. So this is not rational because it gives the reward of minus 1,000. Even if actually if player 2 acts by him or herself, he or she receives 0. This is not rational, so again, this is not an imputation. Finally, for the third one, it satisfies all individual rationalities. However, it does not satisfy the group rationality. As I said before, if all players act together, they can gather the money or the profit of 30,000. But now here in this reward, the sum is 33,000. So where does that additional 3,000 comes from, right? So it's not rational. So that's why this is also not an imputation. So there are three concepts that we've learned so far in this video. First is characteristic function. Second is reward vector. And then the third one is whether that reward vector may be called as an imputation or not. So as I've said before, there are many solution concepts to n-person game. So in the next video, I'm going to talk about one of the ways to find a concept solution for n-person game. So see you in the next one. Thank you.